Matthew had 67 pins. He gives 27 pins to his cousin. For A through C, choose yes or no to indicate whether each number sentence shows how many pins Matthew now has. Let's reread the question and decide if there is motion in the problem. Is this like a selfie, or is there comparing a bigger and smaller number? Here we go. Matthew had 67 pins. He gives 27 pins to his brother. So when he gives 27 pins to his brother, that's like subtracting. And this is what we mean by motion. There's motion here because he's giving. Because it's a motion problem, this is a start, change, result problem, or an add to, take from problem. So now let's go ahead and solve this. Matthew had 67 pins. That's what Matthew starts with, 67 pins. He gives 27 pins to his brother. So when he gives, that's subtracting, and that's the change. And so what is the result? So here's our problem. We have 67 minus 27. Now when we subtract 7 ones minus 7 ones, well, that gives us 0 ones. And now 6 tens minus 2 tens, that's going to give us 4 tens, or 40. Our answer is 40. So one way we can write this problem is 67 minus 27 equals 40. Another way, if we want to use addition, we know that 67 is also equal to 40 plus 27. And we could also write it as 27 plus 40 equals 67. Different ways to express the same amount. So let's go ahead and answer the question. For A through C, choose yes or no to indicate whether each number sentence shows how many pins Matthew now has. So for A, 40 plus 27 equals 67. Well, that's right here, so that works. So we're going to mark that as a yes. That's a yes. And remember, we can rewrite this as 40 plus 27 equals 67. For B, B reads 27 minus 67 equals 40. Well, that's a no. That's a no because these numbers are in the wrong order. They're in the wrong order. So this is a no. And then for C, C reads 67 plus 40 equals 27. Well, that's going to be a very big number. 67 plus 40, if I were to add that, that would be 107. So this is also a no. So A is our only correct answer.